In the last lecture, we discussed about the definition of continuity. So, what type of continuity is there? What is the removal of discontinuity or irremovable discontinuity, and definition of continuity. Also, we taken here the properties of continuous function. If f and g are both two continuous function, then prove that f plus g is also continuous, f into g also continuous, f divided by g also continuous, and so on. So also we taken here the example on continuous functions. So we also take in this lecture. So example. So it is an example here. So examine the continuity of fx. Examine the continuity of fx at x is equal to 0. At x is equal to 0, where the function is given, where fx is equal to x square into sine 1 upon x. When x is not equal to 0, otherwise, so this is equal to 0 when x is equal to 0 here. Okay. Or f of 0 is equal to 0. So examine the continuity of this function. So we solve this example. So what is given here? Let fx is equal to x square sine 1 upon x when x is not equal to 0. So this is the function given. Examine the continuity of this function here. Or f of 0 is equal to 0 means when x is equal to 0, then f of 0 is equal to 0. So that is given here. Okay. So test the continuity of this function x square sine 1 upon x. So as x tends to 0, then 1 upon x tends to plus or minus infinity. Okay. X tends to 0, then 1 upon x, 1 upon 0, that is infinity. So 1 upon 0 tends to plus infinity or minus infinity, depends on the values of x. If it is positive x, the value of x the values of x are positive, then 1 upon x tends to plus infinity, and if the values of x are negative, then 1 upon x tends to minus infinity. Okay, so this is very simple, and hence sine 1 upon x oscillates between plus 1 and minus 1. Between plus 1 and minus 1. Okay. So sine x is a function. So this is the oscillate in between plus and minus 1. For example, we draw the graph of the sine x function. Y-axis, x-axis. So this is the origin. Okay. So what is the sine 0? Sine 0 is 0. Sine 0 is 0. Okay. So what is the pi by 2? Sine pi by 2 is 1. Sine pi by 2 is 1. So what is sine pi? Sine pi is 0. So what is sine 3 pi by 2? Sine 3 pi by 2 is minus 1. This is minus 1. Minus 1. Sine 3 pi by 2. Sine 2 pi is again 0 and so on. Similarly, so the function and so on. So this is the graph of the sine x function. So this function this sin x function is oscillate between plus 1 and minus 1. So sine 1 upon x oscillate between plus 1 and minus 1. So this function is not continuous because this function is oscillate function, oscillate between plus 1 and minus 1. Okay, so this is the sine 1 upon x is not continuous function. But what is the example given here? So limit of fx as x tends to 0. So this is x square into limit of x square into sine of 1 upon x as x tends to 0. So this is what? So x as x tends to 0, so x square tends to 0. So that is 0 into limit. So oscillates between plus 1 and minus 1. Okay. But 0 into this, so that is 0. 0 into this, 0. This is the oscillate function. This is a discontinuous function. But x square into sine 1 upon x is continuous function. So because the limit of this function is 0, so that is finite. So therefore limit of fx is 0, so that is given here, 0. 0. So this value. Therefore the given function is continuous at x is equal to 0. At x is equal to 0. So this is the example, a very simple example. Here, sine 1 upon x is oscillate between plus 1 and minus 1. But x square into this, x square into oscillate function. So this is a continuous function at x is equal to 0. So we take another example on continuity of a function. So we check here the continuity of a function. Okay. Examine the continuity of fx at x is equal to 0, where next example, where fx is equal to e raised to 1 upon x divided by 1 plus 1 upon e raised to 1 upon x, or just no, e raised to 1 upon x. So when x is not equal to 0, otherwise 0 when x is equal to 0. Otherwise the value of fx is 0, so x is equal to 0. So then that's the continuity of this function here. Okay, solution. Okay, so what is the given here function? Let fx is equal to e raised to 1 upon x divided by 1 plus e raised to 1 upon x when x not equal to 0 here. Otherwise 0, x is equal to 0. Means f of x is equal to 0 when x is equal to 0. This value is already given here. So find the limit of this function is equal to 0, then it is continuous. Otherwise the function is not continuous. Okay. So multiplying by e raised to minus 1 upon x to denominator and a numerator, we get multiplying by e raised to minus 1 upon x to numerator and also denominator and a numerator also, denominator and numerator. Okay, so multiply by e raised to minus 1 upon x, e raised to minus 1 upon x. So the function becomes here. So fx is equal to, e raised to 1 upon x into e raised to 1 upon x, means e raised to 1 upon x minus 1 upon x. So that is e raised to 0. So that is 1. E raised to 0 is, that is 1. So what happened? So this is equal to what? So this is 1 plus e raised to minus 1 upon x. Multiplying this by e raised to minus 1 upon x to this. So this is e raised to 1 upon x minus 1 upon x, e raised to 0, so that is 1. And e raised to minus 1 upon x as it is here. Okay. So x is not equal to 0. Otherwise, the value is 0 when x is equal to 0. Okay. X is equal to 0. So now we find the limit of this function, left hand limit and right hand limit. Now, as x tends to 0 plus, as x tends to 0 plus means, so this is the right hand limit. So x tends to 0 from the right side on the real line, okay, from the right side. So what happens? So this is e raised to minus 1 upon x. So this is equal to e raised to minus 1 upon x. So this is equal to 1 upon e raised to 1 upon x. So this is equal to this. 1 upon e raised to 1 upon x. So this tends to what? So as x tends to 0, so this is equal to this. X tends to 0 means what here? X tends to 0. So 1 upon 0. So this is infinity. So this is infinity. So e raised to infinity. So that is also infinity. So 1 upon infinity. So that is 0. So this is 0. What happened here? So as x tends to 0, x tends to 0, 1 upon 0, that is infinity. E raised to infinity. So that is infinity. So 1 upon infinity, 0. So as x tends to 0 plus, so this tends to 0 here. So this is done. So what is the right hand limit? So limit of fx as x tends to 0 plus is equal to, so this 1 upon limit as x tends to 0 plus. So 0 plus means right hand limit. So x tends to 0 from the right hand side. So that is 1 plus e raised to minus 1 upon x. Okay. So this is what here. So this is e raised to minus 1 upon x is equal to 0 here. So that is 1 upon 1 plus 0. So that is 1. So the right hand limit of this function is 1 here. So now obtain as x tends to 0 minus. X tends to 0 minus means left hand limit. So x approaches to 0 from the left hand side. So this is a left hand limit. So that is what happened here. So e raised to minus 1 upon x tends to what? So tends to what? X tends to 0. X tends to 0. So e raised to minus 1 upon x means what here? So all the values on the left hand side, all the values of x on the left hand side of 0, so those values are negative. So those values are negative, negative, positive. So 1 upon 0, so that is infinity. E raised to infinity is infinity. Because all the values of x from the left hand side of the 0, all the values of x are negative. Put all values are negative here. So this negative and this negative is positive. Then 1 upon 0, that is infinity. E raised to infinity is infinity. Okay. So therefore, what is the limit of this function? So that is the left hand limit. So limit of fx as x tends to 0 minus is equal to limit of fx. So fx now. So what happened here? So what is the function? 1 upon 1 plus e raised to minus 1 upon x as x tends to 0 minus is equal to what? Is equal to 1 upon 1 plus, so what is this? So this is as x tends to 0, this tends to infinity, so this is infinity. So this is what? 1 upon infinity, so that is 0. 1 upon infinity, so that is 0. So what happened here? So what is the right hand limit? So the right hand limit, so limit of fx as x tends to 0 plus is equal to 1. But this equal to 0, not equal to limit of fx as x tends to 0 minus. In this case, the left hand limit not equal to right hand limit, then the function is discontinuous at x is equal to 0. Therefore, fx, the given function fx, is discontinuous, not continuous, discontinuous at x is equal to 0. So this function is discontinuous at x is equal to 0. So this is a very simple example here. So now we take here some definitions. What is a bounded set and bounded set, and then before that, what is the bounded above set, bounded below set, what is the supremum, what is the infimum, and so on. So very simple definitions here. So we take here definitions. Bounded above set, bounded above set, bounded above set. Okay, so what is the bounded above set here? Definition. Okay, let a set S, a set S of real numbers is said to be bounded, is said to be bounded above if there exists a number, a real number, a number capital M such that x less than or equal to capital M for all x belongs to S. Okay, so S is a set of real numbers. S is a set of real numbers. All numbers of these sets, all numbers of these sets are less than equal to M, then M is said to be upper bound, and the set S is said to be bounded above. Here capital M is an upper bound. Okay, is an upper bound. So the set S is said to be bounded above set if all the elements or numbers of the set S are less than equal to capital M, then the set is said to be bounded above, and the number M is called upper bound here. So this is the upper bound. Okay, and the set S is said to be bounded above set. So for example, let A be the set of 1 upon n, where n belongs to n natural number set, natural numbers set. Okay, so n is a natural number set, and A is the set of such elements of 1 upon n. So for example, so that is A is equal to, put n is equal to 1, so this is 1. Put n is equal to 1 value, so 1 upon 1 is 1. Put n is equal to 2, so that is 1 half. N is equal to 3, 1 by 3, 1 by 4, and so on. So we get here what? So this is last element will be here, as n tends to infinity, 1 upon infinity, so that is 0 here. So this is the set here. Okay, set. Is it a bounded set? Because so the upper bound of these elements of this set is 1. Upper bound of this set is 1, and all x less than equal to 1. All the elements of this set is less than equal to 1. Less than m means less than equal to 1. So this set is bounded set. Bounded above set. Bounded above set. Above set. Okay? Bounded above set. So similarly, so what is a supremum? Supremum. What is a supremum? Or list upper bound. List upper bound. Definition or simply LUB, list upper bound here. Okay? List upper bound. Okay, definition. What is a supremum? So definition is what here? So let S be a, let S is a set of all, the set of real numbers. Let S be a bounded above set. Let S be a bounded above set of real numbers. Okay. A number m, a number capital M is called a list upper bound, is called list upper bound or supremum of the set S of S of the set S if okay, if one m is an upper bound of, so m is said to be list upper bound. Here m is upper bound. Then we say here m is a list upper bound of m. Yes, when m is upper bound of S, upper bound of S, and m is upper bound of S also, and also if capital N is another upper bound, N is another, is any upper bound of S, then m is less than equal to n here. M is less than equal to n. So, what is the supremum or list upper bound? So that is, let S be a bounded above set of real numbers. A number m is called a list upper bound of S if m is upper bound also, and if n is any upper bound of S, then m is less than equal to n. Okay. So see example. So this is example here. So in this example, so m is equal to 1. M is equal to 1 is upper bound. M is equal to 1 is upper bound of this set here. So we take another, n is equal to something. N is equal to 0.5. N is equal to 0.5. Or just, no. N is equal to something 2 or 100 or 1000 and so on. So just we take n is equal to 2. So all the elements n is equal to, we take here n is equal to 100 or 1000, 10,000 here. Okay. So here m is upper bound. Means what here? All the elements of this set are less than equal to 1 here. So m is upper bound. So we take another upper bound. 2 is also upper bound because all the elements of this sets are less than 2 also. Less than 2 also. So also all the elements of this set less than 100 also. All the elements of this set less than 10,000 also. So this is the meaningless. So this is the meaningless. So there are n something, so many upper bounds are there. But we need only the upper bound 1. Upper bound 1. 1. 1 is the upper bound of this set. 1 is the. So what is the minimum of that? What is the least upper bound of that that numbers is 1 here. Least upper bound of that number is 1. So just n is any upper bound, then m is less than equal to n. So n is 2, m is 1, m is 1, then m is less than equal to n. So n is 2 here. So this is m. This is m. So this is n. Okay. So m is less than 2. So it is not necessary to take this upper bound. So we take upper bound is 1 only, and this is a list of all upper bounds. So that is definition of list upper bound or just supremum. Just supremum. Okay. So this is a very simple example. Okay. So what is the bounded below set? Bounded below set. Bounded below set. Okay. Bounded below set. What is the definition of bounded? So we just discuss about bounded above set. Now we discuss what is the bounded below set. Any set. So how to say that set is a bounded below set? So definition. A set S of real numbers is said to be bounded below. Bounded below. Bounded below. If there exists a number small m. If there exists a number small m such that all elements of that set greater than or equal to small m. All the elements are all the numbers of that set. All the numbers of that set are greater than or equal to m. Then m is said to be. Here m is said to be and said to be lower bound. Is said to be lower bound. Then m is said to be. So all the element of S, so greater than or equal to m, then m is called lower bound and the set is called bounded below set here. So we take also example. So that is, this is the example A. So n is the natural numbers. So this is the example. Say here in this set m is 1. All the elements of capital M, all the elements of this set less than or equal to m. So this is m is upper bound. Upper bound. What is the lower bound? So what is the lower bound? Lower bound is 0. Lower bound is 0. Lower bound is 0. So this is the upper bound. So all the elements of this set greater than or equal to 0. All the elements of this set greater than, so m is 0 there. So m is 0. So all the elements greater than 0. So m is, so that is small m. So this is small m. So this is a lower bound. So this set is bounded above as well as this set also bounded below. So this set also follow this definition. So bounded below set definition. So this set also say here the bounded below set. Okay. So now just we observe the definition here. So infimum. Infimum. Infimum or greatest lower bound. Greatest lower bound or just GLB. Greatest lower bound. So what is the infimum or greatest lower bound? So that is GLB. So let S be a bounded below set. So we take here below. Bounded below set. Below set of real numbers. A number small m. A number small m. A number small m is called greatest lower bound or infimum is called greatest lower bound or infimum of S if small m is is a lower bound of S and small m is lower bound of S, and if small n is any lower bound of S, then m is greater than equal to n. M is greater than equal to n. Okay, this is a definition same as it is the supremum of the set. So same definition of the infimum. Okay, so we take example of this here. So what happened here? So what is the infimum? So 0. So m is equal to 0 is a lower bound. Okay, m is equal to 0. So all the elements of this set are greater than equal to 0. So 0 is called lower bound. Then we take here just n is equal to 0.5 minus or minus 10,000. N is equal to take minus 0.5, something minus 0.5 or minus 10,000. Here all the elements are greater than 0. So m is equal to 0 is lower bound. All the elements are greater than equal to also minus 0.5. Also all the elements are greater than minus 10,000. So what is the greatest of that? Greatest of that is 0. So this is greatest lower bound, or this is infimum. This is greatest lower bound, or this is infimum. So we not require that numbers. We require only 0, and all those numbers, what is the greatest? 0. So this is greatest lower bound. So what is the bounded set? If it is either bounded above set or as well as bounded below set, then the set is said to be bounded set. So we learn bounded set and some important theorem to the next lecture. Thank you. बंद झालं.